All right, guys, welcome to 4.2 Reflections. Let's reflect. Again, the first page of the notes here, we're going to talk about in person. I'll walk you through the dynamic software that is GeoGebra to show you a little bit better understanding in real life or interactive way to see what's happening. For our book notes, though, and for what we'll do on quizzes, this is what we're talking about. A reflection is a transformation. So it's our second transformation. This chapter we had translations, which was a slide. Now we're going to reflect, which is like a flip. And the line of reflection acts as a mirror. So if your pre-image is P and you're going to reflect across the line M, you basically want to go that same distance in that same direction on the other side. And P to P prime ends up being a perpendicular, or the line M ends up being a perpendicular bisector for segment P prime. So that's one way you can think about it. Obviously, the closer P gets to the line of reflection, the closer P prime will get to the line of reflection. And in this image here, you can see it could directly be on the line of reflection as well. But enough talk. It's easiest to understand this stuff when you actually do it. So, example 1. We want to graph ABC with the vertices shown and its image after the reflection across, let's see, in this case it's line x equals 3. So, first I'm going to put 1, 2, 3, that line in. And you guys did a great job last chapter with your Hoibuck stuff, knowing what x equals 3 looks like. So you got that going for you. Now to graph it, let's see, let's go red. So A is at 1, 3. So that's A. B is at 5, 2. 1, 2, 3, 4, 5, 1, 2. And C is at 2, 1. So there's my triangle. And as you can see by this example, sometimes the line of reflection will cut right through the image that you're dealing with. And so let's see where that takes us here. So now the way you do this is if A is 2 units to the left of the vertical line x equals 3, then A prime will be 2 units to the right. B is 2 units to the right, so B prime will be 2 units to the left. And then if C is 2, 1, then C prime will be 1 unit on the other side of the line. So you got a little something like that with your new image. Now it doesn't want actually any, it wants the actual graph of it. So a lot of times if you're reflecting across the line y equals or x equals, then they're going to have you graph it instead of trying to just do it off the top of your head. All right, in part B, in this one, we're reflecting across the line y equals 1. So Hoibucks, line y equals 1, horizontal at 1, and same triangle now. So let's go back red. A again at 1, 3. B at 5, 2. And C at 2, 1. So there's our same triangle. And now we're going to take this thing and reflect it down, essentially. So A is 2 units above, so A prime will be 2 units below. B is 1 unit above, so B prime will be 1 unit below. And C is on the line, so C prime stays on the line. And so our reflected triangle will look a little something like that. And again, guys, it's all about thinking about the line of reflection is going to be the perpendicular bisector between the points. So A and A prime, B and B prime, C and C prime, whether or not it's horizontal or vertical. All right, I want you to go ahead and pause the video here, take a sec, and see if you can reflect across these two lines. All right, welcome back. So hopefully you got a little something like this. 1, 2, 3, 4. There's my line x equals 4. And similarly, so 1, 3. There's my A. B is at 1, 2, 3, 4, 5, 2. And C is at 2, 1. And now reflecting across the line, x equals 4. So now A is 1, 2, 3 units. So go 1, 2, 3 units. Give me A prime. B is 1 on this side, so B prime is going to be 1 on this side. C is 2 to the left, so I'm going to go 2 to the right for C prime. Alright, so it should look a little something like that. And the next one, we got y equals 2. One, 3. There's A. B is at 1, 2, 3, 4, 5, 2. And C is at 2, 1. Oops. So there's the original triangle. A is 1 above, so A prime is 1 below. B is on it, so B prime stays on it. And C is 1 below, so C prime is going to go 1 above. And you got a little something like that. Alright, like a little arrowhead. A lot of times you'll see these images in marketing and advertising, things like that. They just take shapes and reflect them, and they come up with new images and kind of dig it. So alright, so that's our first mission today. Alright, the next part is where this gets into the good stuff here. And these are some coordinate rules for reflections that we're going to have to just memorize or know. When you guys take Algebra 2, man, this stuff gets really hard when it's like absolute value functions or quadratic functions. And you're asked to memorize these things then. So it's a lot less challenging for us, but it's still, you know, it gets a little tricky sometimes. So your general rules, keep it like this, guys. If you're reflecting across the x-axis, then you are going to flip the y value. So if your point starts out AB for all these, you're always starting out AB. You're going to flip the y value when you reflect across the x-axis. When you reflect across the y-axis, you flip the sign on the x value. And then 2 other lines we're going to reflect across. When it's y equals x, you just basically switch A and B. And when it's the line y equals negative x, you're flipping and switching the sign. So that's our 4 things we have to remember here, guys. And it should make sense to us logically, because if you think about it, when you reflect across, you take a point, say it's like 2, 3, and you're going to reflect it across the x-axis. Now it's coming down here. No, it's still 2, but now it's negative 3. So you're just flipping the sign on the y value when you flip across the x. Same thing if I'm going in this direction. If I'm flipping across the y-axis, now you're just going to flip the x value. So those 2 should be pretty easy to understand. When you flip across the line y equals x, let's take a look at example 2. When you're flipping across the line y equals x, and you really don't have to sketch it, but let me just do it for you so you understand it. The line y equals x is a diagonal line like that. So like 1, 1, 2, 2, 10, 10, 100, 100, negative 2, etc. So that's your line y. Y's and x equal each other. And when you reflect across this, the rule tells us to just switch the coordinates. So that's a pretty cool thing what we got here. So it's pretty simple when we do it. So like for instance in this example that I'm looking at here, if I have negative 1, comma 2, it's going to get reflected across the line y equals x to be 2, negative 1. So negative 1, 2 would turn into 2, negative 1. So that's all we have to do though. We don't even have to graph it, guys. For any of these, you're not going to have to graph them. You'll just be able to do them by hand in your head after you know the rules. So again, if my preimage is negative 1, 2, then f prime is going to be 2, negative 1. And then g prime is going to be 2, 1. So just literally just flip the order of the coordinates. Now when we reflect in example 3 across the line y equals negative x, for those of you keeping score at home, y equals negative x is just chilling like this. going downhill with that slope of -1. So now you have to do everything. You got to switch the signs and switch the order on the coordinates. So let's do it. Same points from example 2. So now f prime would be, so I start out here at -1, 2. I got to flip it to 2, -1, and then flip the sign. So this is going to be -2, +1. And then g prime on this one, flip it. So 2, 1, and then flip the signs also. So -2, -1. All right, so there's reflections in y equals x and y equals -x. All right, so monitoring progress. Pause the video here. Give yourself some time. And we'll pick it back up. All right, back again. So here we go. Number 5. We're taking this triangle now, JKL, and first tells us to reflect it in the x-axis. So all that does, party people, is change the sign on the y value. So if j is 1, 3, j prime is 1, -3. If k is 4, 4, then k prime is 4, -4. And if L is 3, 1, then L prime is 3, -1. So that's a flip in the x-axis. Flip the flip in y values. So number 6, now we're flipping in the y-axis. So let's flip the x values. Start out with 1, 3. Give me -1, 3. K, 4, 4. K prime, -4, 4. And L is 3, 1. Then give me -3, 1. So there's your y-axis flips, just changing the sign on the x's. 7. Now we're doing y equals x. So now you just reverse it. Put your game down, but then reverse it. So j prime, j is 1, 3, j prime 3, 1. K prime stays 4, 4. Because it'd be actually on the line. And then L prime, 3, 1 turns into 1, 3. And the last one. Now we're going y equals -x. So I got to flip it and flip the signs. So right up above, it's already done for me. So I'm just going to flip the signs on number 7. All right, so there you go. So hopefully that's pretty easy for you, party people. So those are reflections in the common lines. So these 4 are your most common ones to do, and if it's the ones like from the first example, then you're gonna have to graph it. All right. Now a glide reflection. It's pretty cool. All we do here is we slide and then we flip. So it's 2 steps, but throws it back to the last section also. So what you can basically do is be like, all right, I'll go 1 step at a time. It's going to be a prime, double prime type thing. The translation first. So A prime, what happens to the 3? You got to lose 12 on it. So that puts me at -9. And then the y value, nothing changes. So keep that the same. Then we take a look at B prime. So again, this can be done without even graphing this bad boy. So lose 12 on the 6, that puts you at -6. Keep the y value the same. C prime, lose 12 on the 7, and keep the y value the same. So there's our slide. And then we reflect that in the x-axis. So a reflection in the x-axis just changes the signs on the y value. So it's my double prime. All right, so flipping the x changes all the signs on the y. An important thing to note here, it's from where you ended up. So our first transformation was to slide. So then from there, that's when I do the reflection in the x-axis. And the reflection line and the slide will always be will always be parallel. That's just something else cool about a glide reflection. That's it. Soup's simple. And wrapping up the lesson today, we got lines of symmetry. So I know you talked about this back in middle school, maybe even earlier than that. The figure in a plane has a line of symmetry when the figure can be mapped onto itself by a reflection in a line. So we study lines of symmetry because essentially if you can reflect it onto itself, then think about folding a piece of paper, or folding a shape in general. If you can fold it so it's exactly evened up, then when you unfold it, that crease line is a line of symmetry. All right. So let's go take a look at example 5 here. Identifying the lines of symmetry. Well, this hexagon would just have one straight down the middle. Now, when it's a regular hexagon like part B, oh wait, oh I could go this way too, yo. So that's 2. It has 2 lines of symmetry. Now in this one, man, we got a lot of them here. We can go down the middle of this one, down the middle of this one, down the middle of this one, corners, corners, corners. So you're going to have 6 lines of symmetry if it's a regular figure like that, where all the sides and angles are the same. And then this guy, whew, it's kind of weird. We can go definitely that way, but we can't go vertically at all. So that would only have 1. So they show you a couple different hexagons here and how it could have 2, it could have 6, it could have 1. All right, pause the video here, see if you got these last couple of lines of symmetry. All right, welcome back. A rectangle. You got one that way, right? 2 lines of symmetry for a rectangle. Here you have a 5-sided figure that's all the sides look the same. So that's going to give you 1, 2, 3, 4, 5 lines of symmetry. And an isosceles triangle will just have one cutting straight down the middle, like that. All right, guys. That's section 4.2. Peace!